Hello, welcome to m252 here at Cañada College. My name is Lapuz. In this video, we'll be looking at checkpoint 6.7. This is coming from section 6.2. It says to multiply the series 1 over 1 minus x, which is equal to the series of x to the n, and goes from 0 to infinity. So that's our geometric series that we've used over and over again. Multiply this together to construct the new series for 1 over 1 minus x, basically quantity squared. So it looks like we're going to multiply this series with itself and come up with a new series. This is usually not the most elegant way to do this. It turns out the derivative of this is equal to something similar, and that would be a little bit nicer, but here let's go through the process of multiplication. Now, if we're looking at a series, we actually have an infinite series, right? So let's start off by writing this function that they want us to expand or find a series for. That's going to be 1 over 1 minus x times 1 minus x, all in the denominator, and we know that is equal to 1 over 1 minus x times 1 over 1 minus x, which is the series that they're looking at here. Now, if we take a look at this series, this is really 1 plus x squared plus x to the third plus etc. Right? So if we imagine multiplying this out, let's write down the first few terms like we did for that original series. We have 1 plus x squared plus x to the third, and maybe we'll stop here. I'll just put ... to say, hey, this is going to go on forever. And then we're going to multiply it by itself, the same series. So that's 1 plus x squared plus x cubed plus ... And we're going to FOIL it. Well, it's a little bit more complicated than foiling. We're going to need to do some sort of a distribution. So let us imagine taking this whole infinite series and distributing it over to each of these values. And obviously we're not going to be able to capture every single thing, but let's see what we can write out. So let's start off with 1. 1 times this whole thing is going to be that whole thing. So that's 1 plus x squared plus x cubed plus ... So that's the 1 part. And then now we're going to multiply the whole thing again times x. So that means we're adding this, by the way. After I have an infinite number, we're going to add, now we're going to add what? We're going to add 1 times x, so that's x. X times x, so that's x squared times x, that's going to be x cubed, etc. So that's the next term. So we found the first term, we found the second term, infinite, and then now let's maybe do one more to see what happens. So let's take this whole series and multiply it by x squared, and what is that going to look like? That's going to be x squared times 1, so that's x squared times x, that's x cubed, x squared times x squared, that's x to the fourth, and then x to the sixth, and then ... All right, so that captures that third multiplication, and technically you'd go on forever, and of course you don't have forever to do. So what we'll do now is we'll just figure out how to combine like terms and see if we can find a pattern. So how we're going to combine like terms. It looks like if we go any further here, which technically we would, then the higher order terms here, would be generated. So the next term here will have the least order of x to the third, and then it'll be x to the fourth, x to the fifth, etc. And then the term after that will be x to the fourth, etc. So they just come up with higher order terms. And a little side note, This is called HOT for higher order terms. Okay, we're gonna ignore that and hopefully be able to count what's happening here. So what is happening here is that we're gonna look at the constants first. Well, it looks like there's only one constant happening here, right? Because the higher order terms will have no more constants, and this first infinite series would be the first time we're going to run, and first and only time we're going to get a constant. So that is the constant of 1 down here. Okay, so next the linear terms, x terms. So we got one x term here and one x term here, and everything else would be higher order terms. So there are no more higher order there's no more linear terms, the x terms, but we only were account for 2 of them. So there's only 2 x's that come up. All right, now let's take a look at the square terms. There's a square term here, there's a square term here, there's a square term here. And there's going to be no more square terms here because the lowest, they would be higher order terms, and the lowest would be x cubed. All right, and I think we only counted 3 of them, 3x squared. And if we continue on, we'll see that there's a cube term here, there's a cube term here, and there'll be a cube term for the next 2 terms. And then that would be it. Oh, there's a cube term here also. So that's 1, 2, 3, 4. And then so there's going to be 4 of them. Okay, so there's going to be 4x cubed. And then you can kind of see at this point what's happening here. It looks like there's a pattern. And the pattern will go on if we take this to the nth power, x to the nth power, as we're trying to see the pattern. We take a look at the coefficient in front of that and compare it with a power. It's going to be 1 more than the power. So it looks like it's going to be n plus 1 is the coefficient that is for the x term. All right, and that would make it really super easy to write down our series because we found the generic term. This is going to be n plus 1 times x to the nth term. Now, just to be clear, we should also say where we're starting, and I think if we started at 1, this would be x to the first power, and this would be 1 plus 1 is 2. That's the second term. So the first term would probably make this 0, because then the x would be x to the 0 would be 1, and then n plus 1 or 0 plus 1 would be 1, and that is in fact our first term. Okay, and so I think that's what we got. So we got the series kind of spelled out, and then we got the series written out in a nice summation form. And that's it. All right, I hope that helps. Good luck.